All right, so critical points. So critical points are some point C in the interior point of the domain of f. So somewhere in the domain where uh, either the derivative is equal to 0 or the derivative is undefined. Okay, so these are kind of points of interest, right? Critical points, points of interest. And so here are some examples here. If we zoom in on this graph here, we can see that here we have a situation where the derivative is 0. That's a critical point because it could be a maximum or a minimum. We'll talk about that more in a second. Or we can see these points. Those are where the derivative is undefined. Remember, derivative is undefined where we have some kind of sharp point, and so, or some kind of edge or things like that. So these are places where the derivative is undefined, and we can see that those are local mins and maxes as well, right? The derivative doesn't equal 0, but they are minimums and maximums. And then we have a couple situations where here the derivative is 0, but it's not an extreme, right? It's not an extremum. It's actually just a point of inflection, right? Where the graph levels out to 0 and then it keeps on going up, right? And the same thing could happen going the other way, going down. But so sometimes we have, like I call these fake out points, right? Where it seems like it's going to be a max or a min, but it seems like it's going to level out and go the other way, but then it just keeps on going the same way it was going before. And then we have this situation where the derivative is undefined, and that's where instead of the slope being 0, the slope is actually, we actually have a vertical tangent at that point, and so the slope is undefined or no slope, right? And so there's a situation where this is not an extreme either, right? But it's a point that is a critical point. Okay, so these are all critical points, and some come out to be extremes and some don't, right? And so that's why so critical points are important because it gives us our extremes, but it also gives us some other things called points of inflection and some other points that are important. All right, so let's see. And then Fermat's theorem says if we have a local extremum at C and it's differentiable, okay, then the derivative of that extreme at that point is 0. Okay, and we know that, right? Like we've talked about this before, but if we have a horizontal tangent line, that means, well, it doesn't always mean it's going to be an extreme, but if there is an extreme that's differentiable, that means the tangent line is going to be horizontal, right? In other words, it'll be 0 slope at that point, right? So the derivative will be 0. All right, and the same thing for a minimum, right? If we had a minimum, and then at that particular point where we had the minimum, the tangent line would also be horizontal, and so the slope of that tangent line would be 0, so therefore the derivative would be 0 as well, right? All right, so when we try to identify critical points, we try to find places where either the derivative is 0 or the derivative is undefined, and so that'll be kind of what our key is to do some of these examples, is to figure out, hey, when is this derivative 0? So we can find the derivative, set it equal to 0, and or we can look at where is this derivative undefined, right? And remember, undefined values are where we have a 0 in the denominator a lot of times. That's one of the key places, and or just places where we have some kind of break in the function, in the derivative function.